Okay, so in this video clip, we're going to take a look at the Black Model 1976 for valuing an example provided by John C. Hull. So basically, we're going to use these parameter values of f equal to 127.09, x is equal to 110, the exercise. The risk-free rate is 10%. The volatility is 8%, and the time period is equal to 1 year. So we take our Python code. It's worth noting that the approach here is one that was provided by Espen Hogue in his textbook, The Complete Guide to Option Pricing Formulas. And I think chapter 1 or chapter 2, he sets out this framework, the generalized Black-Scholes. It is quite useful because it means we can piggyback off Black-Scholes model to infer the value of the Black 1976 analog, right? So, and also Davis Edwards in his GitHub set out some Python code for option pricing, and he makes this explicit, and you should take a look also here, some interesting code here. Okay, so let's just copy then the code, the Python code, and so basically we copy, and you might note that we have the values already loaded in for the parameters, and we'll just go to an online compiler, online. I'm going to use ONLINEGBD, and we must select which code we're working with, so Python 3, and then remove the existing code, paste in fresh, and what we want to estimate is basically we have, as before, a value for D1 and D2, so this is consistent with the formula that we've invoked so many times now, D1 and D2, and then we're going to estimate the value, in this instance, the value of the call, and then subsequently the value of the put. Okay, so this is the numerical example we're following based on John C. Hull option futures other derivatives example set up for a bond option futures. And okay, so we just hit run here, and if the value, if it's a call option, so we do have values for the call option, it was 15.58, and for the put option it was 0.12, so 12 cents. Okay, now we've set a call option, and we're getting for the call option or for the put option. Let's just check this. So have we a call or a put? We've put in for the put, and we're getting 12 cents. If we change it to a call option, just so change this to C, then it will be 15. I think it's 58. So let's just run and compare 15.58, which is the same 15.58 419. 15.58 419. Okay, so the results are consistent. Okay, so that's a very simple implementation of Python in ONLINEGBD, and we can see the code is working well.